Okay, the first practice problem for IR topic which not include any spectrum. Okay, I will divide the explanation. One is when you are given a question without the spectrum, how you're going to answer this type of question. And then the other one is when you have a spectrum. Okay, so for the first question, okay, dehydration. Okay, so not only you need to refer to correlation chart, you also need to understand some of the reaction, some of the simple reaction that you need to know what are the conversion. Okay, what are the conversion from a starting material to the product, and then you need to relate what are the changes from the IR data. Okay, so the word here is dehydration. So just imagine if you don't know what is dehydration, you don't know how to answer this question. Yeah? Dehydration means removal of water from cyclohexylmethanol. So one, you should know what is the process. Second one, you should know what is the product or what is the starting material, the structure. Cyclohexylmethanol. Okay, this is the structure of cyclohexylmethanol to prepare methylene cyclohexane. So basically from the alcohol to the alkene. Okay, so the question is explain using the IR spectrum. Explain here is not a wording, not a sentence. You just need to list down what you see in the IR, even though this question is without the spectrum, but you can refer to the correlation chart and you can refer to the structure of the compounds. Okay, the IR spectrum that different between pure cyclohexylmethanol. Okay, so this is the structure of cyclohexylmethanol, pure methylene cyclohexane, and then what happen if you have a mixture of both two. Okay, so first you need to draw the structure. So this is a structure, and then you need to list down all the bonds present in this molecule. So you can see the OH there, you can see the CO there. Okay, for methylene cyclohexane, you can see the CHsP2 for the alkene, and you see C double bond C for the alkene. Okay, why CHsP3 is not included? Because the question asks you the different. For the first compound, you see CHsP3. Second compound, you also see CHsP3. But since this is two same, it cannot use to differentiate between these two compounds. That's why we cannot put CHsP3 as one of the answer. You just need to put whatever that differentiate between these two compounds. That is the thing that you need to put in the list. Okay, so now you already know what are the bonds present. And then for the frequency, you just copy from the correlation chart. Why you can put a range here? Because you don't have a spectrum. Okay, if you don't have a spectrum, then you can put the range. Just copy from the correlation chart. Okay, so for this one, you need to give the bond together with the frequency. The bond together with the frequency. Okay, the next one is when you have a mixture, what you see. So mixture means you have these two compounds together. So from the spectrum, you might see all these four together with the frequency. So this is how you answer this type of question. Yeah, explain is not in terms of wording. No, for IR is only you need to list down everything. That is how we answer a question for IR. Okay, yeah, for the second question, okay, this is different type of question. Yes, for the second question, you are given a molecular formula. Okay, so this is the molecular formula, and you are given the frequency of the molecule. Okay, so you are given the frequency. So what you need to do, you need to match the frequency with the bond. So C8H10O. So automatic, you know, it might be an alcohol it might be an ether. So you need to list down all the possibilities, depending on the molecular formula. And then it might be a ketone because 1O. It might be an aldehyde. Okay, what else? Carboxylic acid, no. Amide, no. Ester, no. Acid chloride, no. So this is all the possibility. Okay, now look at the frequency given. So when you have alcohol, ether, ketone, aldehyde, you already know what is the general formula for each class of compound. Let's say if we have an alcohol, we have an ether, we have a ketone, and we have an aldehyde. Okay, so automatically you know if I have an alcohol, I must see the OH. So the OH is, what is the frequency of the OH? It's 3000 something. So this is might be in the range. But the thing is, you have 1710. Remember 1710, anything between 1800 to 1600 Cm-1 is belongs to carbonyl compound. Carbonyl is normally 17 something, but it's only amide is less. You just can refer to the correlation chart. Yeah, so the problem with the student, they have the answer in the correlation chart, but they don't know how to use it. Okay, so in between 1800 to 1600, it might be a carbonyl. So you can see here you have 1710. So automatic, you know, this is a carbonyl. So your compound might not be an alcohol, your compound might not be an ether. So you only have these two choices, whether it's ketone or aldehyde. So remember, if you have an aldehyde, you have the CH aldehyde. So the frequency for CH aldehyde is 2800 something, 28 something, and 27 something. N, and the word N here. N means for CH aldehyde, the frequency must be these two frequency, because from the spectrum they appear as a two peaks. Okay, but when you look at the list, you don't see any CH aldehyde. So automatic aldehyde is not in your list. Okay, so what is 1640? Okay, 1640 is normally for C double bond C. Okay, so you have all the information here. You have 1710 as a carbonyl. And when you have C double bond C, you must have the CH sp2. Okay, so this is how we answer this type of question. So from all the given information, you need to find out what are the bonds that match to the given frequency, and from there you know, okay, 3050 is your CH sp2, C double bond O for your ketone, and C double bond C from the alkene. You have all this information, you need to fit this information to the molecular formula. So C8H10, okay, you need to remember back CnH2n, okay, plus 2, or CnH2n minus 2, and CnH2n. Okay, since the number of carbon is more and then the number of hydrogen is less, so it might be a double bond there. Okay, and you have the carbonyl. So this is the structure of the compound that correspond to the IR data given and fit it with the molecular formula. Okay, so for A, I already explained. I hope for B, you already have some information how to solve this kind of problem. So anything that you don't understand, you can ask me.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.